Hey everybody, this is our lesson for Monday, October 4th. We are in chapter 3, lesson 1, so we're in a new chapter now, and we're going to be evaluating new information from Mars. So the first thing I want you to do is go to 3.1, activity 1, and you're going to do the warm-up. So go ahead and pause this video, complete the warm-up. Make sure in that second box you explain why you made the claim that you made, and then be sure to hand that in. All right, let's go ahead and move on to activity number 2. This is called the evidence gradient. So our chapter 3 question is, how can we decide which is the best evidence about the geologic process that formed the channel on Mars? We have so much information, and we need to start thinking about how we're going to gather the information to write a scientific argument. And so when scientists construct an argument, I just want to remind you, it's exactly the same thing that you do for race. You're going to make a claim, so you're going to restate and answer the question. You're going to cite evidence to support your claim, and then you're going to use reasoning to explain how the evidence supports your claim. And of course, if you use more than one piece of evidence, you're just going to repeat step number 2 and number 3. So in the warm-up, you thought about how the information that you have so far might be used to support one of the claims about the channel on Mars. And remember, in chapter 1, we considered images of landforms on Earth to see if they were similar to the channels on Mars. The images gave us really good evidence about what geologic processes might have formed the channel. So that's, we're going to see these again in something called evidence cards. And then remember, in chapter 2, we used models to get additional evidence about whether flowing water or flowing lava could have formed the channel on Mars. So we've got a lot of information, but we really need to kind of talk about how this evidence can be used, if it's good evidence or if it's kind of weak evidence. And so this is what we did together in class. I'm just going to kind of lead a discussion with you, and if you guys have any questions or you're not quite understanding my reasoning, please send me an email and let me know, and I'll try and explain it, okay? So we've got this tool called an evidence gradient tool. And it's going to help us kinesthetically organize our evidence so that we can see it kind of mapped out, and then we can use that evidence. And of course, we want to use the most convincing or even good evidence in our scientific argument. We do not want to use weak evidence. So this is a PDF that's in today's folder in Schoology. So go ahead and copy this into your GOM folder. Okay, so we're going to use this evidence gradient tool literally in every single unit that we do, and it's going to help us evaluate the quality of our evidence. And you might remember using something like this evidence gradient tool in 6th grade. I hope you do, and we'll just continue using it on. So one thing we have to do is always remember to consider how believable and accurate the source is, and whether the source may have been biased. So just like in language arts or in social studies or really any class, if you're going to use a source, it has to be a good, reliable source. We've gotten all of our evidence from NASA, and so obviously NASA is a good, reliable source. They are not biased, and so we're okay. So let's go ahead and look at those evidence cards. So in class, the kids actually had these evidence cards. They're labeled A, B, C, and D. And if you look at evidence card A and B, they're the evidence cards that we have from chapter 1 that showed the geologic processes. And these are just photographs that somebody took from an airplane. And then evidence cards C and D came from chapter 2, and we were using models to see if, maybe water or lava could have formed the channel on Mars. So what we're going to do with those cards, in class, the kids literally took the cards and arranged them on their evidence gradient. And I'm just going to talk to you about where I would have put mine, or where maybe I would like you to put yours, and why we did that, okay? As I talk and as I show you this, if, again, you're not understanding my reasoning, then make sure that you let me know, okay? So I'm going to go back one slide. And looking at the evidence that we have so far, is there any evidence that is what we would call the most convincing evidence? If you look here on the evidence gradient, up at the top, that dark gray area, that's reserved for the most convincing evidence. In other words, this is evidence that says without a doubt that one claim is right. So do we have any evidence that only says, hey, the answer is only lava formed that channel, or only water formed that channel? And the answer is no, we don't. So if we look at evidence card A and B, these are showing pictures. And if you remember, they were pictures taken from an airplane. And we used words to describe what these landforms look like. And we used forms like loopy and curvy, straight, narrow, wide, gnarled. We used all of those words, remember? And as we were talking about them, we realized that you could compare the landforms that were made by flowing water with the landforms that were made with flowing lava. And some of them are similar. So you can see a channel on formed with the flowing water could be narrow. And the same could be said from flow of lava, that there could be narrow. But then they're also different, like flowing lava is gnarled, and we don't see anything gnarled for the flowing water. And so when we go to decide where the evidence cards A and B should go, they're actually down in the weak area. This is good evidence to know kind of for background information, but as far as making a claim and using evidence to support your claim, this is actually really weak evidence. And so what we'll do is we put the cards over in that weak area, and then I want you to get used to using reasoning to explain why that goes there, okay? And so I said evidence card A and B just show photographs of landforms on Earth. They show similarities and differences of the geologic process. There's nothing concrete. So it's kind of wishy-washy evidence. I'm going to have you guys pause and copy this reasoning onto your evidence gradient. Okay, I'm going to go back a couple slides. Now let's look at evidence cards C and D. So evidence card C showed flowing water, and evidence card D showed flowing lava. Where would you put those? So if we look, I know some of you guys might be really tempted to put it up in the most convincing, but the problem with that is, didn't we see that water formed a channel? Especially the first lab that we did. The second lab, when we increased the elevation, it kind of formed a canyon. But the first one, for sure, it forms a channel. And evidence card D definitely forms a channel. And so since they both are evidence that show that either one of those could form a channel, we can't put that in the most convincing because there's only one answer, only one claim that can be right. And this one shows that both of them could be. But it's actually really good evidence because it literally shows us the formation of those channels. And so we're going to go ahead and put that in the good evidence. And the thing that you need to remember is the limitation of evidence cards C and D is that they're models. So let me read what I have here for evidence card C. I said, evidence card C showed how water can move and deposit grains of sand, forming a channel. And evidence card D showed how a channel formed when wax cooled at the sides and warm wax flowed down. The important thing for us to remember, and actually the reason why we can't say it's the most convincing, is because these were models. And do you remember key concept number 5 states that models are used and they're really good about showing us some really important information or details about geologic processes. However, they're not the same as the real thing. And so even though it looks like this is great evidence, it's a model. and it does have its limitations. So we can't use that. We can't put that up in the most convincing, but it is good evidence. So I'm going to pause, have you guys pause and finish filling that out for me. Okay, so we've got some new information about the channel on Mars. NASA called me on Saturday, and I was so annoyed at first, NASA calling me on Saturday on my day off. But they said, hey, we've got some new evidence. Wanted to see if you would go ahead and present that to your students. So I said, okay, sure. And in all seriousness, this is real data about Mars that was gathered by instruments on spacecraft orbiting Mars. So we speculated about the elevation, but this detailed information, I'm going to let you guys pause and read those bullet points. This actually shows us that, yes, what we had thought to be true is actually true. There is a much higher elevation for the channel and surrounding area. So all of that in red is 250 meters above all the blue. So what does that mean? It means that whatever formed that channel moved from the top down, okay? And we've got this triangular shaped landform right there. And it looks to be a different color than what is surrounding it. And in fact, the next image you're about to see is the same image of the channel that we've been looking at, but it's zoomed in on the area at the base of the channel. So the kids got this evidence card E, and it shows, listen to this. NASA scientists found a triangle-shaped landform at the bottom of the channel on Mars. Based on information gathered from satellites and the Curiosity rover, scientists believe that this triangle-shaped landform is made of what? A different type of rock than the rock around it. What that means is whatever material is inside that triangle is different than material outside the triangle. What does that mean? What can you infer? How did it get there? We stopped class at this time, and we'll talk about it tomorrow. Whoops. I was trying to make like a really cool exit, and I don't know how to do that. So, okay, here it is. I'll see you guys tomorrow, hopefully.